Hi guys, welcome back. Today we are looking at synthetic division. So yesterday you should have watched the video that talked about long division. Today we are learning about synthetic division. And honestly, today is a day I'm excited about. I love synthetic division. It is so different from anything that you've probably ever seen before, and yet it is so fun. I know that sounds crazy. Some of you are like, whatever, Miss Solner, it is not fun. It is fun. It's so crazy and so much faster than long division. It's crazy how much faster. Okay, so let's get started. I'm going to explain how it works, and then we're just going to dive right in, and then I'll show you kind of how it relates to long division, and you'll see how much faster it actually is. Okay, so synthetic division. The only downside to it, which is why I still teach long division, is synthetic can be used only if the divisor is in the form x minus a, or more generically, if it's x plus or minus some number. So if I'm dividing by like x minus 4, I can use it. If I'm dividing by x plus 2, right? I can use it. That's good. That's good. If I'm dividing by 2x minus 1, wrong, can't use it. If I'm dividing by x squared plus 1, wrong, can't use it. It has to just be x and then either plus or minus just a random number. Okay? If it's anything other than that, you have to use long division. Okay? So a lot of times, most of what we do, you can use synthetic and it works great and it's fast. But when you come into the times where it doesn't fall into that form, you have to fall back on the long division. Okay? All right, so step by step, kind of what it looks like. Step 1, you will write the coefficients. Coefficient is just the number in front. Just a reminder there. So write the coefficients including zeros. So if the problem goes from like x cubed plus x minus 1, it's missing right in here. In order, there should be an x squared. It goes from x cubed, it's missing the x squared, so you'd have to put a 0x squared. You'd have to recognize that, and then the x, and then the 1. Okay, if something would have like x to the 4th minus 2, right, you're missing things. So you have an x to the 4th, but you're missing the 0x cubed, you're missing the 0x squared, you're missing the 0x. Okay, so you have to recognize when those pieces are missing. It's like you want to stair step down, 4, 3, 2, 1, and then nothing, right? The constant number, that's like your nothing. 4, 3, 2, 1, and then like a 0. Okay, make sure it's in standard form, right? You want them to go in order, highest exponent down to the lowest. You will omit, meaning leave out, all the variables and all the exponents, which is great. It just simplifies this whole process. And then for the divisor, so what you're dividing by, use the opposite sign of a, or in other words, what x equals. So if you were dividing by x minus 2, what does x equal, right? We solve these in our head all the time, right? If you set that equal to 0, x equals 2, right? Positive 2. So if you had x plus 4, what does x equal? Well, x would equal negative 4. So that's where it says the opposite sign. It's like you went ahead and set it equal to 0 and solved it. That's what you're dividing by. Okay? So what happens when you're doing something like this, and you're dividing by that? Think back to long division, and every time we had to change your signs, right? Every single time you went through it, change your signs, change your signs. So here, I changed the sign once. And I'm done. I don't have to keep changing my sign. I change it once to figure out what I'm dividing by, and then I don't ever change it again. Let's see what all this craziness means and how it looks, okay? So I want you to divide, use synthetic division. I want you to divide x cubed plus 5x squared minus 7x plus 2 divided by x minus 2. So again, this is what I'm dividing by. What does x equal? Well, again, if you set that equal to 0 and solved that, x would equal positive 2. This is what you're dividing by, right? A positive 2. All right, so here's the setup. It looks a little different. It's almost like an upside down division sign. And then the directions said to put all of the coefficients, the numbers in front. So remember there's an unspoken 1 there. So there's the 1 for the x cubed, positive 5 for the x squared, negative 7 for the x, and then a positive 2 for the constant. All right, notice nothing was missing. It went x to the third, x squared, x to the first, and constant. They went in order, nothing was missing. All right, and I already established I'm dividing by a positive 2. All right, you have to change the sign or you have to solve that. All right, so with synthetic, whatever that first number is, you will always drop it down to start. Now, I always like to put the arrow there because what I see happen is people start doing their math early and then like they put numbers there and then the problem gets weird. So go ahead and put an arrow right underneath there, drop it down. Now, to do synthetic division, all you have to be able to do is multiply and add. And I know this is a lot of times, this is where we mess up. So grab your calculator if your multiplying and your adding skills aren't the best, okay? So what you're going to do is you are going to multiply 2 times 1, which is 2, and then you add what's going on in here. So 5 plus 2 is 7. Then again, you're going to multiply 2 times 7, which is 14, and then you're going to add negative 7 plus 14 is 7. Okay, from here we're going to multiply 2 times 7, which is 14, and then you're going to add 2 and 14, which is 16. Everybody got that? You know what? Hold on. Let's try this one more time. And I know you're like, really? I just watched that. But I wrote all over it. I'm going to do it again without writing all over it. So I can kind of show you the next step because we're almost done. All right, so hang with me. Let's do that one more time from the beginning. Upside down kind of division looking thing. Coefficients. Whatever signs in front stays with it. That's why that's negative. I'm dividing by x minus 2, so that means x equals 2. That's your change of signs. Drop the first one down. Multiply at the angles, right? 2 times 1 is 2. And then the columns straight up and down, that's where you're going to add. 5 and 2 is 7. Multiply 2 and 7. That's 14. And then we're going to add negative 7 and 14 is 7. Multiply 2 times 7 is 14 again. And then you add 2 and 14 is 16. All right, so there I just went through it twice. Now, we're almost done. So since my problem started with an x cubed, we are going to drop down the exponent by 1. Because again, look, synthetic always has to be a plain x. Well, this plain x, if you divide out an x, you're left with an x squared. All right, and that's a positive 7. So you're just going to fill your x's back in. So we had an x squared. This would be your x to the first. That's a positive 7. This is your constant. And then anything, that extra number on the end, that's your remainder. And remember, remainders go over whatever it was you were dividing by in the first place. Well, that was a terrible line being drawn. Sorry about that. So we had x squared minus 7x plus 7 plus my remainder was 16 over x minus 2. And we're done. Now, right now you might be like, that was a lot of work. But really, that's really fast. Now, let me real quick go through the same problem with long division, and I want you to see the difference, okay? Let me erase this, give myself some space down here. All right, so if I set up with long division, we'd have to write all of this out. Right, and divided by, sorry about that, x minus 2. All right, long division, you'd multiply the first one. What do you multiply x to get x cubed? it'd be x squared. And then you distribute x cubed, distribute negative 2x. Then you'd have to remember to change your signs. That cancels. Now as I'm doing this, take a look at the numbers that you're seeing versus the numbers up at the top in synthetic. Notice this 5 and 2. Notice the 5 and 2 at the top. All right, so we would add these together, and that would give me 7x squared. Bring the rest of the problem down, and we would start again. What do you multiply x to get 7x squared? And you would tell me 7x, and then you distribute. We get 7x squared. Distribute negative 14x. Are you seeing the numbers? And then don't forget to change your signs. That's gone. That gives me a positive 7x plus 2. And you'd start again. What do you multiply x to get 7x? Well, you multiply by 7. And distribute. I get 7x. Distribute gives me negative 14. And then you would change your signs. That cancels. That would give you 16. That would be your remainder. 16 over x minus 2. So obviously that took a lot more work and a lot of more opportunities for me to mess up actually, because every time I did every step I had to remember to change my signs every single time. All right, synthetic, I changed it once and that was it. And then it's just pretty straightforward. All right, so hopefully you think that is as cool as I think that is. I know I'm a big nerd, but that to me is awesome. That is so cool. So the lazy mathematician in me, like I always tell you I am, loves it because I can be really lazy doing this. All right, let's take a look again. Next problem. Since I am dividing by, it's just x plus or minus a number, I can use synthetic division. So if x plus 2 equals 0, that means x equals negative 2. This is what you are dividing by. All right, so we're going to set this up. I know I'm dividing by negative 2. And we're going to go ahead and put in our coefficients. Remember, there's an unspoken 1 there. So we have 1, negative 14, 51, and negative 54. Again, I did the mental check in my head, but I didn't say it to you guys. We had an x to the third, x squared, x to the first, constant, right? They kind of stair step down, nothing was missing. All right, so you drop the first one down, and then we multiply. Multiply negative 2 times 1 is negative 2. And then we add, right? You're always adding on the up and down columns. Negative 14 and negative 2 is negative 16. Multiply at the angle, so negative 2 and negative 16 is a positive 32. And then we always add up and down. That gives me 83. Multiply negative 2 and 83 is negative 166. And then we're going to add. And adding that together is going to give me a negative, let me do some basic math here in my head, negative 220. All right. So once we're done there, we're going to go ahead and go back and you put all your x's in. So this started x cubed and we divided out an x, so we're always dropping it by 1. So now we're down to an x squared minus 16x plus 83, and that means this is my remainder, x plus 2. There we go. Isn't that so much faster than doing long division? And I tell you what, once you practice this a lot, you get really fast at it. So if I didn't have to say anything out loud and I just went through a problem, super fast. All right, moving on. Number 9. We're doing great, guys. So setting this one up, again, I'm looking, this is x cubed, x squared, x, constant. Great, I got all my pieces. All right, so let's set this up. This is what I'm dividing by. So again, think if I solve that, x would equal negative 3. That's what I'm dividing by. So negative 3 goes on the outside. Coefficients, so the 2 from the x cubed, the unspoken 1 from my x squared, negative 8 from the x, 5 for my constant. We always drop down the first term, and we start from here. So multiply negative 3 and 2 is negative 6, and then we add 1 plus negative 6 is negative 5. Multiply negative 3 times negative 5 is a positive 15. And then we add negative 8 and 15 is 7. Multiply negative 3 times 7 is negative 21. And then we add, and that gives me negative 16. All right, putting my x's back in. This started x cubed. I always divide out 1x. So this is going to drop to an x squared. This would be minus 5x, positive 7. And then this last number then is my remainder, x plus 3. Awesome. So back to that question we'd asked before, is x plus 3 a factor of that problem? And the answer would be no, because there is a remainder. That gets really important in the next section that we start to recognize that. All right, dividing again. Now take a look at this one. Do you guys notice, look at the problem, is anything missing? All right, I have an x cubed, but wait a minute, I dropped to an x. So really, I'm missing that 0x squared in there. And then I have my x and I have my constant. So if you're missing a piece, you have to put in the 0. Now with long division, we didn't have to worry about that. We just had to watch kind of our like terms and how they lined up. If you forget the 0 with synthetic, it's wrong. Okay, it's very, very wrong. And I'll show you kind of the difference here in a minute. But let me show you the right way to do it. All right, so the right way to do it. Here we go. So setting this up, we would have a 1 for the x cubed, a 0 for the x squared, negative 57 for the x to the first, and a 56 for my constant. Okay, that was dividing by x minus 7. That means x equals 7. So that is what we are dividing by. Drop down the 1, and then we multiply. 7 times 1 is 7. Add 0 plus 7 is 7. Multiply 7 times 7 is 49. Adding negative 57 and 49 gives me negative 8. Multiply 7 times negative 8 is negative 56. And then 56 and a negative 56 make 0. Okay, putting back in, this started x cubed, and we divided out 1x. So we're down to an x squared plus 7x minus 8 plus, that's your remainder. So if there's a 0 for a remainder, it means I don't have a remainder. So x squared plus 7x minus 8 is the final answer. That's what you get when you divide. So is x minus 7 a factor? The answer is yes. Since I got 0 for remainder, it is a factor. Now, trying to help you guys out a little bit, it's really easy to get kind of moving quick and you don't notice that that x squared term was missing. And if you don't put that in there, it's wrong. Okay, so a couple kind of hints I've learned, things through the years. After you put your x's back in, you should always have a term that is your constant, right? Just a plain old number after the x. And then you should always have something for the remainder. Now, I had 0 for a remainder, but there was something there. If there's not something there, you know that you forgot your 0 somewhere, okay? So as you go back, put your x's in and you stair step down. X squared, x to the first, I have a constant and remainder. If you plug them back in and you don't have constant and remainder, even if that remainder is a 0, you messed up. So let me show you the wrong way to do it. I know, what teacher shows you the wrong way, right? So let's say you didn't notice that that x squared was missing, and you went 1 for my x cubed, I have a negative 57 for the x, and then you have a 56 on the end. Okay, just humor me. Let me show you kind of how this works. So you drop down the 1, 7 times 1 is 7. Negative 57 plus 7 is negative 50. 7 times negative 50 is negative 350. And then you're going to add those together, and you are going to have 56 minus 350. That's going to give you a negative 294. Okay, so yeah, my numbers got kind of weird, but that happens sometimes. But like, here's your red flag. You started with an x cubed, so this should have been x squared, then this would be your x, and then this would be in the place of a constant, but you didn't have a number over here for the remainder. Okay, so if you plug your stuff back in, right, x squared, x, constant, there needs to be a remainder number, even if that's a 0. So that's a huge red flag that something is wrong. Okay? All right, let's try the next one. This one, if we're going to divide, right? So I'm looking here, I'm like x to the 4th, x cubed, x, oh, wait a minute. You're missing the 0x squared in between there. And then you have your constant. And then I'm looking here for what does x equal? Wait a minute. Can you do synthetic division when you're dividing by something like that? And the answer is no, you cannot. Okay, so if the directions say use synthetic division, you can't. All right, because you have to divide by x plus or minus a number. Okay, so you cannot do synthetic with something like that. Now, if the directions just said divide, then you could do long division on this, no problem. All right, let me give you a little side note for a minute here. Let's say I asked you to divide x to the 5th minus 1 divided by x plus 1. If I asked you to do that, I just want to make sure that we're okay on how this sets up. So if you go to set this problem up, right, divided by that, so you know x equals negative 1. So you could set that up. And then filling it in, you have a 1 for the x to the 5th, and then you're missing a lot of stuff, right? So you'd have a 1 for the x to the 5th, 0 for the x to the 4th, you'd have a 0 for the x to the 3rd, a 0, that's terrible, 0, for the x squared, you'd have a 0 for the x to the 1st, and then the negative 1. Okay, I just want to make sure you're seeing that a lot of times you can have a lot of zeros because you're missing all those pieces stair-stepping down. Okay, so we can go ahead and finish this out quick. Drop that down. So negative 1 times 1 is negative 1. That is 0 minus 1 is negative 1. Negative 1 times negative 1 is 1. 0 plus 1 is 1. It's not very exciting math. Negative 1 times 1, negative 1. And then we add 0 and negative 1 is negative 1. Multiply negative 1 and negative 1 is a positive 1. 0 plus 1 is 1. And then negative 1 times 1 is negative 1. Negative 1 plus negative 1, ooh, there's good math. Negative 2, my numbers finally changed. Plugging back in, that was x to the 5th, so this would be x to the 4th minus x to the 3rd plus x squared minus 1x plus 1 plus negative 2 over x plus 1, right? Whatever we're dividing by comes down. But again, notice I have all of these stair steps, and then I have a number for the constant, which is the one that does not have an x, and then I also have a remainder. Okay, if you go through, let's say I didn't do that from the very beginning, I mean, like, look, I have a 1 for the x to the 5th, and I have a negative 1, and I'm dividing by negative 1. So negative 1 and 1 is negative 1. I get negative 2. So it's x to the 4th minus 2x cubed. No, that just does not seem right. You're missing so many pieces, right? You got to remember those zeros. Making sure that you always have something on the end for a constant and something on the end that's a remainder, even if it's a 0 on the end. Okay? All right. As always, guys, if you have questions, do not hesitate to reach out. Myself, Mrs. McCourt, we are always just a one phone call, one email, one text message, whatever you need. We're here for you guys, waiting for you to hear from you. If you have questions, please reach out. Hopefully you had as much fun with synthetic division as I like it. I hate that I can't teach this to you in person because I get so excited about it. But otherwise, if you guys have questions, reach out. Otherwise, I will talk to you later.